right, looks like we're live. Welcome. We got the open source 100% solar off-grid EV camper van. So all these models are available. There should be a link for the Onshape model and the Discord. So I got some good input in Discord. So I thought I'd just go live and start working on it a little bit, kind of clean up our model and make it a little more accurate. So again, welcome and thanks for joining me. Let me get some music going. Tell me if it's too loud or about right. So we are going to work on the body, the van body here. So that's this part here. And how I made this one was I just took some images off the internet and pasted them in and sketched around it. But they're not very accurate. So you can see here, this is the image I got. And I just kind of drew a line tracing around it. But you get a lot of distortion in these camera pictures. You can see the back of the van here. It's not vertical. I just kind of hacked in a line there to make it as good as I could. And you can't see the wheel wells very good. It's kind of difficult. And then I used parameters. These are some scaling factors and the wheels here, the dimensions. But what we've got is someone on Discord found this nice spec sheet. So this has got some pretty good info here. All about the bright drop. And we're on the 600. It's got all the features and kind of an easy to read format. And we are going after the 600 with the larger battery. Forget where the detailed specs are. Let's see. Here we go. So we got the 600. Maybe make that a little bigger here. And all-wheel drive max 303 miles. City estimated. Highway is kind of low, but that's probably because it's not very aerodynamic. And then the combined 272. So obviously if you drive slow enough, you can get over 300. And if you drove maybe 55, you might be able to sustain over 300. Interesting thing is the 400 and the 600, the all-wheel drive have the exact same numbers. And if you look down here at the note, you can see these are just estimates. They don't really have exact numbers when they publish this data. So I don't expect the 400 and the 600 to have the exact same range with the battery. So these might be more crude than we think. But the nice thing is we've got these really good screenshots right out of NX. So GM uses NX, I think it used to be Unigraphics CAD software. And these are color schemes that look familiar when I was there. So I'm pretty sure this is a straight screen grab, which means all the dimensions, all the proportions here are going to be perfectly accurate. Not the greatest resolution, but I'll take that lower resolution any day with accurate proportions. So we'll just snip this in and start sketching around this section here. Where's my snippet tool? Grab that. Edit and paint. Probably need to invert that, flip it around. Save. Go. I'll hide my screen here because I don't know if it's going to show my file structure when I save this. So, file, save as, pick a location. And then we'll try and import that. Okay, I think I got it imported. Now where did it go? Here we go. So we've got that. And then we need to go to this body here. We'll activate this. Okay, so we've got that in there. Now, I probably should have tried to remember how I put these pictures in here. Edit image. I'm going to drop this image in. There we go. Now we need to scale it. What's the best way to scale it? Now, I know this dimension here is accurate. So if we scale it to that. Oh, I've got it locked. Delete that. Delete that. Oops. Man, I'm kind of rusty. This might be, maybe I should have done this before I went live and figured out how to use this. It's scaling it as I move it. But what I want to get is these two dots right in the center of each wheel, and then I know all the proportions will be right. So I can go back and add a dimension. Let's see. So 400. Make sure the aspect ratio is locked. Okay, that's good. Oops. And does it let me change it? Nope. Okay, we're good. For some reason, it's locked on this constraint here. So how do I show constraints? Been too long since I used this. Of course, I just learned it a few months ago, and then I put it up and haven't used it since. There we go. Delete that. Now it'll let me move it. No, it's still locked. Oh, okay, because I've got it locked to this. There we go. Let me delete that. Okay. Now it's letting me move, but still not up and down. Somewhere here there's show constraints. I'll just search it. Onshape. Shape. Show constraints. Man, there's no like simple way. I wish they would just give you the answer real quick. All right, I'll keep trying. So here's all of our constraints. Search tool. Oh. About constraints. Show, no. don't have too many people in the live here, but if anyone knows how to show constraints in Onshape, let me know. This is frustrating. It's probably right in front of me somewhere. Show constraints. Just got to be able to move this up and down to get the scale right. Well, at least we can get it kind of lined up. Say 7. Let's see, 7. Nope, it needs to go a lot more. 700. So we got parallel constraints here. Got this constraint. What happens if I delete that? Oh, there we go. Okay. Now we're in business. Now I can get this lined up. Put that right in the middle. Oh man, that picture is not, oh, you know what? I think when I did this originally, I had to rotate it. Edit image. How do I rotate it? Either that image is not perfectly square, or I gotta rotate it. Let's check the image and see. Here's the image. If I draw a line from wheel center to wheel center, is it perfectly straight? No, it's not. What? Well, so much for this image being just so perfect. It's not even level. But also looks like maybe the wheels aren't. Let's check the top. Maybe the image is and the tires are just at a different position. Yeah, no, the tires are at a different ride height. That's odd. Okay, so we'll ignore that discrepancy. It looks like the scale is pretty good. So it's still kind of lined up. So in terms of the overall dimensions, we're good. And then we can just shift it down a little bit. No. Get it lined up like this. You know, my original sketch wasn't too bad. It's pretty close. Well, that's nice. So we'll line it up here. We'll use that as kind of our datum reference. Or maybe the front, because the front's got that complex spline. I don't want to have to redraw that. But that spline is so far off anyway. Let's go ahead and redraw it. So we'll go back, we'll call this our datum. That corner right there, and then we'll do everything off of that. I think I just had some of these fixed so they wouldn't float around too much. Like that. Yikes. So we got a nice straight edge there. It's going to be way more accurate than what we had before. It doesn't look like I need these two lines anymore. So a lot of these have all kinds of fixed constraints I got to get rid of. Delete that. Or I can always just blow out the whole line and redraw it. But sometimes that gives you issues in subsequent operations when you cut and splice the model. if you delete a surface and add it back, it makes it more difficult. So in light of that, let me leave these alone for now. All right, now you take that, fix it. Where's my fix? There we go. Fix. There's a hotkey for it. Okay. Select, fix. Okay. Now it won't jump around on me. That point is fixed. So we can delete that, delete that, delete that. Come on, let me move it. Okay, so let me fix this point. Then it locks that line down. So this curve has got two tangent points. Tangent there. There's another fixed constraint. Let's see, will that let me move it? Let's me move that. Horizontal constraint, okay. Don't need that. There we go. Now it's letting me move stuff. We'll fix this point, lock that in place. Yeah, it's still locking everything down. Control Z, Control Z, Control Z. I don't know, maybe I'll just redraw it. That might be easier. So I'm just gonna fight this thing the whole way. And we got a dot here just floating. Get rid of that. Draw a line. And we'll draw a circle. Not two circles, one circle. Actually, a 3-point arc might be a little easier. We'll do that. Point here, here, and here. And then we'll connect it there. And we'll just connect that now. We'll draw a little segment in there. Not sure what's going on. It's kind of discontinuous there. Maybe we can fix that later. Line that up. Yeah, that's easier. We'll just delete this stuff. Trim. Get that lined up. Three-point arc. Like that. This is where we're going to see how easy it is with Onshape when you really hack something up. Is it going to blow everything up for the rest of the model or no? I don't really know what's going on under here, so we'll just kind of rough it in. Get rid of that, and then we'll do a new spline. Still in trim. So this is where that piece of metal ends, and this is all new. So we'll do one big continuous spline through that. There, I think that captures everything. Oh no, we moved it. That's because we redrew it. That's okay. Let's just see what happens if we go with this. Watch it blow everything up. Oh yeah. That's what I was afraid of. Yeah, if you redefine that sketch, it blows everything up. I don't know, maybe we'll just undo this and we'll come back, because now it's gonna destroy the whole upper level. Yeah, we just lost everything. But hey, you can see what it looks like inside without a van. So let's go back and undo that. I forgot. Oh, you know what? So I created a version right before I made all those changes, so we can go back and show changes. We can go back to this version and make this active, and then just pretend like we didn't do that. We can also do branch 1. So we can create a branch of that, and then we can hack it up even more, and if we like it and it works, then we can merge it back into the main model, but at the same time we can just use this original version. So there, pretend like we just didn't do all that, but eventually it'll be good to go in and get all that redefined, but that might take a while. As you can see how slow it was just to get to where it didn't work anyway. So let's see what else we got. Last time we kind of figured out a couch situation and checked the dimensions for the inside, but you can tell, let me chop this up so we can see inside. Get rid of that. Section view. So we cut the top off. We can cut the side panel off. We can cut the back out like that. So you can see in the, get a better view here. I've chopped out these windows here, and these are the main support. And one of the questions I had was, what's going on in the corner here? How can we tie into that? But if we look at that spec sheet, it's got some really good images. We can see what's going on. Here they've got the materials labeled. So these are the composite panels, these green pieces, and all the substructures, steel, and the whole top half of this thing is all aluminum. And all this portion is aluminum. And we can see inside of there, somewhere here, electrical schematics. Yeah, there's some sections here. You can see this is all sheet metal aluminum here with a composite top, and it looks like it's tied right into those vertical supports. So if we mount this big solar array to the top, we have this rail here, should be quite structural. and it ties in directly to the supports. Or if we don't want to go right to the rail, we can go right to those supports. So here's a better one. So here we're looking inside. This is the roof. Let me grab a picture, show you what this would look like actually inside the van. So this is the back of the van, and these are these supports. And I didn't know what was up in this area, if it was just cosmetic sheet metal or if this was structural, but it looks like this is all structural. So we could tie into that rail that runs the full length, or we could tie in right at these points here and get into the structural element. And it looks like they've got two overlaid here. My guess is they have two instances open and they didn't clean it up. So maybe one's the 400 location and one's the 600 location, but you have this ghost image which isn't real. But you can see it's got a bent, what looks like a bent curved tube that ties into the top support and the vertical support, and then a really structural sheet metal piece that's bolted, maybe welded in place. Yeah, there's some welds on it for sure. So if you tie into this with that solar array, it will be really good structurally. Oh, David's asking if I had any luck with the company that does solar directly to CCS charging. I've been in contact on and off. They're not super responsive, but last I heard they weren't working on it. Well, depending on the company. So there's Empower, which is working on it, and then there's also the 4x4 Electric. They were working on something as well. Let me pull that up. Search it on YouTube here. Actually, I think I have it saved on I've subscribed to their channel. There it is. Yeah, so these guys were working on one that they used in their vehicle, and they're working on commercializing it. But last I saw, it was still kind of prototypey, and they had some issues with it. It wasn't like something you could go buy and use right away. So fortunately, we don't have that, but that would be a huge plus, not have to go two conversions, DC, AC, then back to DC, definitely. Yeah, I think for now we might be stuck with it, but I think we can plan for both. And then whatever we come up with can go in this section here. And maybe there's different versions. Maybe you have an all-in-one AC version, and maybe you have a direct DC to DC charge solution. The thought is to have the solar panel junction box, edit section view. So these panels will tie in series, so each string will be one series, and maybe we can tuck the cords or the cables inside this sheet metal structure here for all the panels and come to a junction box on the roof right in this corner, which would be right next to our electrical. And then there would be some kind of fairing on the front to deflect air around the solar array. And so you'd have all that covered, and you could tie in right here. And it would be nice to have battery backups, have a large extra battery here. And they make these all-in-ones. This is a Victron, but they make these all-in-ones that have 120 volt and 240 volt split phase. So you can run any 240 volt, which is the charger. And the charge port is on the side here. If you look at the wheel well, you see the one in the back is a little wider. That's because in this box section over here is the charge port. So maybe we could tie in internally, or just have an external plug, kind of like it did on the Tesla, where it just, there's a little door here in the corner, like a little cat door or something, that you pull the plug out and just plug it into the side when you're parked. I mean, you can't charge when you're driving anyway, so that might be just as easy. But one thing is the, let's see, I don't want to mess with the body on this thing just yet. So maybe we just kind of do some shopping around and figure out what goes in this thing. In fact, if we go to Onshape here, I'll duplicate this. Let's see, let me pull it off another screen, see if I can find it real quick. Yeah, you've got very important things that you need to include, like coffee maker. So this is something someone modeled up in Onshape, and they did a really good job. No prints, but it's all available to check out, download. But it's a classic espresso, and they have different configurations. So we can go to the current today's version. And we should be able to do all the same stuff in our version. So and then I think we can even render this. Oh, to edit it. So if you're looking at this camper van and you want to make any edits, you can't edit my version unless I shared permissions, but you can make a copy and then you can edit all you want. So like, let's say we wanted to modify this, we could create our own here. Well, I'll do that later, but you can create a copy, you can throw it in your model, you can do all kinds of fun stuff. But for mounting, we've got this desk here, which is just kind of roughed in, but this is a huge desk. And I've also thought about, maybe you want, some people want to have a place to store kayaks or boats or bikes or maybe even a motorcycle, and you want to be able to bring it in through the back. So you might want to make this desk have a section that pops out or lifts out so you can drive something in, store it in the back. But let's go to this. And you can see the dimensions here. Yeah, larger than what someone have at home. Yes. So if you click on it, you see it's 75 inches, which is really large. But basically I just took the desk and put it to the whole width of the trailer by 30 inches deep. And then this little section here is 33 inches and 18 inches. And I'm kind of torn between metric or inch. The whole van is, and all automotive stuff is all in metric, but if you're trying to fabricate anything out of wood or anything like that here in the US, it's all inch. So for some of the stuff, I'll type in an inch dimension, but the units behind everything that it's actually computing in is all metric in millimeters. So you can type in anything you want. You can just type in, 10 feet and it would convert it. And these are huge speakers too. The idea was the van could be, something for everyone. So if you wanted to have an office, you wanted to have a recording studio, like this little audio interface, this is what I'm using right now what you're hearing through is this audio interface here. And then a large monitor TV that could lift up. And I found some mounts or stands that are designed for standing and sitting. So you could attach a monitor or a TV to it and it can lower down, but it has like over 20 inches of vertical travel, so you could raise it way up. So when you want to go sleeping at night, this would come down, and then your TV/monitor or whatever you end up using comes up. And maybe the speakers have some kind of air strut or something where they sink down. Ooh, don't want to do that. Where they sink down below, and there's some kind of raised studs that the bed locks down onto. So and then the chair could just maybe put it on its side or something and roll under the bed. Or maybe you don't have the desk. Maybe you want to keep it simple and you just want to have a permanent mounted bed. Get rid of the desk and leave the TV there, and it can swing out, move around, and then you can build out a bunch of storage underneath here, kind of have a garage. It's got the garage door style for now, so you could have it to where it opens partially and it still blocks off the interior. And then this whole area here is kind of your garage area for tools and stuff you don't want inside the actual volume of the camper. You could put a door to access it, but that would be nice. And the AC unit is just something I pulled off of, I think, GrabCAD. Actually, let's check that out. I might have to sign in here real quick. Is it GrabCAD or CAD Grab? Yeah, so I'm not signed in, but this is great because they have models that are built in different CAD packages, and sometimes you get a native model, which is really nice. So I think you just type like AC unit, and you can see what people have modeled up. Like this here, they did a nice job on. That's actually really incredible. And it looks like they designed everything in SolidWorks. So you go to download files, and they have to be logged in, and it'll tell you what native file formats you can get it in. So if you're just shopping around for models and you don't want to create it yourself, this is a good resource, GrabCAD. Got a few windows closed here. Oh, hey, Andy. Just popping in. Yep. Just kind of slow here, just getting used to this live streaming. We'll see how it works. Eventually, it'd be nice to have a couple guys live streaming simultaneously. We could work on it, kind of collaborate, start designing this stuff together. Does it have climate mode in the van? So that's something that Tesla does really well. As you can say, keep climate and it'll keep it, or you can put it in camp mode and it'll stay on all night long. I sat in one of these vans, what was it? Sometime last year, and I didn't see that option, but that's something that you think GM might be able to update, you know, kind of do the over-the-air updates and include. I did test it though to see if you even needed an air conditioning unit. So it was probably 80 degrees outside. You know, this is Detroit, Michigan, kind of late last summer. It was a warm day, and I closed all the doors. It was parked out in the sun, and I walked into the cab, which is up here. You can't see it. I don't have that modeled out. I turned AC on high, and I put the vents to kind of shoot it up into the back area here, and just kind of hung out for about 10-15 minutes. And it was comfortable, but if it got a little hotter, I don't know that it'd work as a reliable solution. So I've got an AC unit up here to kind of cover that, but it would be really nice if you didn't even need that. You could just use the HVAC system in the van and then just charge the van and not even worry about it. Now, is anyone here in the live, have you guys used Onshape before, or any other CAD packages, SolidWorks, NX, or anything? I'd be kind of curious to know. I'm more of a SolidWorks guy, and I just started playing with Onshape recently. Started by the same people that did Onshape, which is actually kind of a funny story. The guy who started, I don't know if you're familiar with the blackjack team at MIT, and they go play gamble, and they had a system figured out where they could, you know, pretty much guaranteed win, and they were making lots of money doing that. One of the guys on that team made a bunch of money and invested that to start SolidWorks, and then SolidWorks was purchased by Dassault Systems, and he stayed on for a while, and then he left there to do Onshape, and then Onshape was purchased by PTC, Parametric Technology Corp, I think, and they were makers of Pro-E, Creo, and this is kind of their user-friendly intro CAD version, which means they've got kind of the innovation of SolidWorks and the founders of SolidWorks, but they've got the financial backing of PTC. So you got both. You got kind of the comfort that they're going to be around. It's not just going to disappear when profits don't work out or something. And you've got the creativity of the SolidWorks team. We probably need some extra duct work for the back for the AC. Yep. 3D modeling used to be my day job, but I moved on. No desire to go back. Nice. Yeah, for me, it's kind of a hobby. 3D modeling. Well, I've done it professionally a little bit, but not a whole lot. We got someone uses Blender. Very powerful for animating and 3D printing. Yeah, I've seen a lot of people use Blender, and you see some really cool images of the Bright Drop van. It looked like they'd been done in Blender, and they look just like the real thing, photorealistic. But dimensionally, I don't think they're very accurate, and it's usually just a shell model. It's just surfaces, so you don't get the solid model for portion. And you've got FreeCAD. These free versions just groom you for the paywall. Yeah. Yeah. So Onshape, their take on it is as long as you keep everything open in public domain, it's 100% free. But if you want to wall it off and have your own professional proprietary stuff, then it's a pay. And I think it's $2,500 a year, which is a lot for a hobbyist. So if you keep it open, it's good. But if you're doing it professionally and you've got an engineer making six figures, $2,500 a year is not much to get them fully supported. And then you don't need advanced hardware. They could do it on a MacBook Air or just a basic laptop in the web browser, which works pretty good in Chrome. If you hit F11, it pops full screen and you don't even realize you're in a web browser. Maybe we go shopping for some solar components here, because I just pulled that off of Victron. Victron Solar, or Victron Energy. So Victron's really good. They make really good components. The problem with Victron is they cater more to the European market. So it's difficult to get US voltage and 60 hertz. They do it. And the split phase is hard to get. But they have some of the best products in terms of robustness and reliability. So you got your inverter charge. And this is, I think, what I've got in the van is the multi-RS solar. And you go to downloads. I think it's in somewhere here. You can get the actual 3D model. Yeah, so you can get an STP file. I think that's step. So you can download the step file, which is what you're seeing here. Am I doing 3 strings? Yes. So you've got 1 string on each face, and the plan is to make it where you can drive around like this, or you can fold them up and then they can track. Now if you're tracking with the sun, you can keep 2 of them pointed towards the sun, and you only need 2 trackers, so 1 for these 2 combined and then 1 for this top panel. However, if you were driving around, you had them flat, you would probably want a 3 string, but those are pretty rare unless you get individual charge controllers. So if we go back to Victron, let's look at the data sheet. This one is really nice. So you can connect two PV arrays. So it's got two trackers, and you got your 48 volt battery, which is good. So these are the high frequency switching inverters. They're not the low frequency that have the big transformer, which is really heavy. Those are known to be a little more robust, and they can handle surge currents better, but they're a lot bigger and heavier. Well, let me guess, you get a free copy by promoting the software. No, I wish. Maybe. I'm using the free version, and then I also have a 6-month trial for the professional version. The only difference between the professional and the free is I can do renders. So once I lose the free trial, then I can't do renders anymore. So this is an example of a render that I just kind of threw in there. So with the free version, you don't get the renders, but you get everything else, which is pretty sweet. So if we look here, back to the Victron, DC voltage, so that's your typical 48 volt battery, full charge, discharge, and it covers, that voltage range is big enough that it'll cover lithium and lithium iron phosphate chemistry. So pretty much any of those batteries in that 48 volt range will work. And then it's 230 volt and 50 hertz, but if you look down at the disclaimer here, you can change it to 240 and 60 hertz. So that's pretty good. However, it doesn't do split phase. So if you needed 120 volt, you'd have to put another inverter or another transformer and step it down, which they make those, so it wouldn't be too bad. And the power continuous output, it's around 48 to 5,000. So you're looking at about 5,000 watts out. Peak power, this is what Victron is really good at, is they conservatively rate it. So if you get a big surge, it'll do it. It won't wimp out on you. They're super efficient, and their zero load consumption is really good. So 20 watts just to idle it, which is pretty good. The other thing is a lot of the Victron equipment, their base trackers, or charge controllers, I should say. Products, solar charge controllers. A lot of these are only good to like 100, 150 volt or something. They can't do these really high volt strings. But with this, you can get 450 volt and startup voltage 120. So once your solar array hits 120 volts, you can start using it, and the max is 450. Let's see, go back to the comments here. I have a smaller Victron for a 12 volt camper battery. I think you can link multiple of them together if you want. Yes. Yeah, so we could do 3 of them. The only problem is their voltage range. These solar panels are pretty high volt. I forget the voltage when you string all these together. Although, we should include it in here. So you should have access to this too. If you go Excel tools, and that'll pull up this, which we worked on last time. There's not a whole lot here just right now, but eventually it'll fill out. So we could put the solar array, we could kind of mock up the solar array in here and get all the min-max voltages so we can match it to the charge controllers. Yeah, no problem. My mistake. It's hard to tell if YouTube Home Shopping Network. Yeah, yeah. Yep, I'm not selling anything just yet. Eventually it'd be cool to actually build these vans and sell them. The idea is that you could build or buy as much as you want. So we design it all open source, and then I get a shop and start building them. You could buy the whole thing, or it's all there. You could just buy the van and do it yourself. There may be a few components that end up being proprietary, like let's say a supplier wants to make an actuator for the project, but they want to sell the whole actuator. They don't want to open source it. Then you'd have to buy that whole package. You wouldn't see the internals, but you could have multiple suppliers, or we could even design our own and then compete it. But if there's something off the shelf that's already out there, rarely can you actually beat that price. What inverter did I use for the Cannonball? Yeah, that was the Solarc Arc 5K. This one here, I didn't get it from these guys. Actually, current connected. These guys had the best price and the best support. $5K. The disadvantage to the 5K is it's either 240 volt or 120 volt. You can't do both at the same time. But it has some pretty good specs, like the PV input power, 10,000 watts. Startup voltage 120. It had 2 solar trackers. The limit I had was the battery. It's 100 amps on the DC battery side, 48 volt. So if you're at 48 volt, 4,800 watts is all you could get. Zero load consumption, 60 watts. I think I measured like 62, so that was right on. Weight is 53 pounds, which is really pretty good for what you're getting, you know, all in one. And the price, it's the same price I paid, what, 2 years ago? 3,000. So even with inflation, this thing is still the same price. So this is a pretty good unit here. And current connected too. They have some good YouTube channels if you subscribe, where they kind of go through how to set up and run it. So that's pretty nice. Yeah, it's similar to the EG4 6000 XP. Although I think we looked at that last time, and the EG4 does split phase. So you can get 240 volt or 120, which is pretty cool, which I think we would need. But who knows, this thing is 2 years ago, so they might have something better by now. So anyway, so you got that for Victron. You got the solar charge controller. They got another one. What was it? Oh no, it was this one. Sorry, we're on the same one. Data sheet. Yeah, because it has everything built in, and this is what I was looking for. Max power. So this is where it gets kind of tricky with this one. It's 3 kilowatt per tracker, 6 kilowatt total. And if we look at our system, if we put these two on one tracker, the 2 side panels, that's 4,000 watts, and this would be 2,000. So it's designed for a symmetric system. So if we use this, we wouldn't be able to extract the full power. So we would almost need a separate, you know, classically Victron gives you separate components for everything. They're not a big all-in-one company right now. So with that, we'd have to go separate components. And if we do that, inverter charge MP3. Now we want just the charge controller. Solar charge controllers. Again, these don't have the high voltage, but they've got this one here. We'll check the specs sheet on this. Data sheet. So this, again, it's a high voltage. It's 450 volt, which is good enough for those large panels. And what I like is it's got twice the current. So my Solarc was 100 amp, and this one you can get in a 200 amp version with total solar charge power of over 10 kilowatt. Maximum efficiency 96, same voltage range, and this one's got 4 trackers, which is really cool. So what we could do with 4 trackers, and each tracker is 4,000. So with 4 trackers, we could take this van, we could put each panel on a separate tracker and have a 4th tracker spare. So if you wanted to set up another array, which I don't know, I'd say it would be a lot of work, but you know, you never know. Maybe you've got like a covered shelter or a carport with a solar array on top of it, and you park next to that. You could plug that directly in, so you could have some PV inputs you could just directly plug in and get another 4,000 watts. So if we went Victron, I think this would be the one to do. This one right here, for that huge total wattage. And it's pretty small and light. Look at this. 13 kilograms. What is that in pounds? About 13.7 times 2.2-ish. So 30 pounds. And you've got an MPP tracker with 4 trackers with 4,000 watts per tracker with a huge voltage range. Highly efficient, 96% efficient. And what is the idle power? That's kind of important when you're not making much power. I'm sure it's right in front of me, but I don't think it's too much. Could use more but cheaper MPP controllers. Yes. In fact, Andy, do you know of any that'll handle, you know, upwards of 400 volts? Because most of the smaller ones here don't. And I don't know the price on this one. I think this is, if I had to guess, this is around 2,000. I'm not quite sure. But it's Victron, so it's going to be bulletproof. And their app is really good. And you can connect it to their web server, and you can have all your stats anywhere. So if you wanted to park this thing, you know, at a property and leave it there, you can monitor it all remotely. Yeah, working with 600 plus volts, three strings of 3 panels with 6 trackers. Yeah, another small fold-up array on the rear. Yeah, in fact, maybe, well, I don't know if you'd want to do that, but if the door was another array and it could open up. But yeah, you could have another array swing out from the back here. Another thought is if you get rid of this garage door, it'd be nice if it was a ramp, so it would just fold down and be a ramp or a deck. So it could fold down and stay, you know, it could fold down and stay kind of parallel like this, and you have like a little deck on the back. Or it could fold all the way down and be a ramp for loading stuff in and out, and then also close up. It's got a Mr. Power controller, cheap and do 160 volt. Well, you know, let's just put the panels in there since we're talking about them. Let me pull up the data sheet on the panels. So for reference, these are the panels I use for the Cannonball run. These are 110 or 100 watt panels. And Maxeon is working on a similar but different 330 watt panel. And depending on which cells, they can get 340 watt. And originally they're supposed to be peel and stick. So you peel off the back, stick them to the roof, and they're 4 millimeters thick. And the dimensions are designed for, you know, in the US they have these roofs that are, it's kind of like a fabric that's stretched over the frame of the roof. And these are designed to fit between those supports. So if you have a rooftop somewhere, instead of putting a ballast or drilling it and fixing mounts and all this heavy stuff, you know, you got thousands of pounds on your roof. The idea is, yeah, you don't get an angle, but the panels are so easy to install and so lightweight that you can go on any roof and just stick them down and you're done. So they're industrial panels. They're designed to probably last 20 years. They've got a high efficiency, almost 21% efficient, and they use the same Maxeon high-grade cells. So the thought is these would be really good. They're industrial panels and they're thin and lightweight. I talked to Maxeon a little bit about these panels, and they do have a thin film glass face on them, so they're not real flexible. You know, they show it kind of flexing, but it's not a flexible panel with like a polymer base. It's a glass face panel, and obviously if it can go on top of a roof, it probably has some kind of hail rating and stuff like that, so it should be durable enough. But the idea is to go with this panel if we can get it. So let's just start putting that in. Oh, enable editing. let's see. Probably just easier to type this in. So we've got nominal power. $320, $330, $340. Power tolerance, panel efficiency. Oh, that's cool. They put that in there. I won't type that out just yet. We're really interested in the voltage because we're going to multiply that up and see what kind of MPPT controllers we need. 0.6, 56.9, 58.2 units. Rated current 578, 581. And I don't know what the price difference is going to be, but since this is a mobile installation, we're probably more willing to pay for premium power density than if this was a big static installation on a rooftop. So we might just want to stick with these higher rated ones. Open circuit voltage. So this is going to determine our inverter voltage max. 65.4. 65.7. Let's see, I dropped a charger on the display and it cracked it. Company sent me another one for 20, which is easily replaced. But I get to get hot and lose efficiency if stuck with tape. Yeah, so these charge controllers do heat up and lose efficiency. In fact, that's what I like about Victron's spec sheet is they give the specs at different temperatures and you can see your power drop as it gets warmer. But it should be inside an air-conditioned cab, so you shouldn't have to worry about that. And I'm hoping that the aluminum, sheet metal aluminum wing structure will be thermally conductive enough that it'll keep the panels cool as well, because that also has a big effect. Short circuit 6.27, 6.28, 6.3 amp. Max system volts 1000 volts. That's nice. Fused at 20 amps. Yeah, power thermal coefficient, so negative 0.29%. Kind of lost the units there. Let's see. Percent per degree Celsius. I don't know what the baseline is, you know, what the starting temperature is, but yeah, every degree extra you lose 0.3% efficiency. And the same for the voltage and the current. So as it warms up, it's going to drop down. And then let's see, we have an array of, I think it's 6. We got 1, 2, 3, 4, 5, 6. So 3 panels of 6. So we'll just kind of cartoon it in here. 1, 2, 3. So that'll be our array. And you know, I think I did this similarly somewhere else. Let me see if I can copy and paste some of my previous work. Yeah, here. I did all this before. So let me just put those numbers into this, and then we can do our number in series, number in parallel. Time. Now let's see the comments here. Oh, yeah, you're talking about the panels at high temperature. You lose watts. The glass metal frame panels dissipate the heat better. Yep. And always have a gap, but fix those panels to an RV isn't optimal. Yeah, if you just slap these on top of an RV, it's not good. Yep, and people get burn marks on the top of the RV. Yep. Yeah, so we want to have, not only the wings have aluminum, but the structure over the RV is some kind of aluminum that would conduct heat out as well. So, why don't we just take this? Can we just drag it in here? Yeah, well, we'll fill it out and then we'll drop it in. So, nominal power. We'll just convert this over to these sun power panels. Power tolerance, we don't have 3. Oh, it's better. So it's better than the sun. It's +3, plus or minus 3%, plus or minus 3%. Rated voltage, drop that in. Rated current, drop that in. And then open circuit. Yeah, okay, it's in the same format, so I can just paste it all in at once. Okay, thermal temp coefficient. Power thermal coefficient. -0.29, and these were 30, 35, and 20, so they're better than the flexible ones. So that's the same. That's the same. And we don't have this yet, so I'll delete this out. We don't have that, we don't have that. Oh, panel mounts with a gap actually cool your roof. I bet they kind of produce a nice convection currents and kind of draw cold air across your roof because it's hot on top and cool below. Voltage thermal coefficient is -156.6. That looks more. The same units, millivolt produce. Yep. Oh, it's bigger because these are bigger panels, so it's not necessarily worse. It's just on an absolute scale, it looks worse. Current. I don't think we have current. Yeah, we do. It's 2.9 milliamps per degree C. So 2.9. And it's the same for all of them. This is 1000 now. That's good. And I can delete my note. Copy that across. Series fuse, they're fused at 20. 20. Weight. Let's see, what's the weight on these? Oh, lost music. Oh, can you guys still hear me? My music output quit on my end. Alright, I'm going to do something here. I'm going to unplug it and replug it. I'll see if that breaks something. Alright, you can hear me. Okay. I lost my music, so... because it looks like my audio interface just died. So I switched over to something else. How's the volume? Is it too loud? It looks like my audio interface just died. So I switched over to something else. How's the volume? Is it too loud? Oh, audio's fine? Okay, cool. All right, well, we're back in action then. Yeah, I think my I've been having issues with my audio interface just randomly cutting out. All right, well, we're back in action then. And I guess it finally cut out and it wouldn't reboot. I kept unplugging it, plugging it back in, and it wouldn't relive itself. So I'm back on my old Cannonball Run USB-C mic now. So All right, where were we? Okay, got a few delays at first, but now it's good. All right, where were we? Yeah, just let me know if there's any issues with the audio, and I'll just keep going. Let's see, weight. Yeah, just let me know if there's any issues with the audio. Thought I saw the mass here somewhere. I'll just keep going. Let's see, weight. Thought I saw the mass here somewhere. So is this eventually going to be a production van, like an option for the Bright Drop? That would be cool. We're just going to design it, see what happens. But the van's production, so anyone can go buy it right now. In fact, they've got huge incentive discounts. You can get the base model for like just over $40,000, and the fully decked out one, the MSRP is like $90,000, and you can get almost $40,000 off if you include every possible deduction. Or, well, I guess some of it's price right off the top, and some of it's if you get the tax $7,500 tax credit. Well, I guess some of it's price right off the top. All right, weight. Where's the weight? You get the tax $7,500 tax credit. Oh, here it is. 10 kilograms. Okay. All right, weight. Where's the weight? 10 kilograms. 10. Okay. And 10 kilograms. We've got how many in series? We've got 6. Number in parallel 3. Let me make sure all these formulas look good. Parallel 3. Bit out of my budget on a Hungarian salary. Yeah, 40,000 US is still a lot of money. But considering a truck in the U.S. costs $50,000, $60,000, it's a pretty good deal. But yeah. But considering a truck in the U.S. costs EV battery capacity, I think this has got a 177-ish. EV battery capacity, I think this has got a 177-ish kilowatt hours. So this is the battery capacity on the Bright Drop van. Actually, let's just check that. Let's see if it has. So this is the battery capacity on the Bright Drop van. Actually, let's just check that. Let's see if it has. That's the battery capacity. Here it is. Useful energy, 173.3. That's the battery capacity. Here it is. So we'll just put it in exactly like it is, 73.3. 173.3. And just a note, useful energy, it's actually a bigger battery, but they put that in. That's the worst case scenario. You're going to get that much energy out after it's degraded, and maybe it's running hot or something like that. So there's more in there than that, but that's the rated. So then this is kind of an estimate days to full charge. And what is it calculating from? Daily kilowatt hour ideal. And this is just a simple 6 times factor, and it looks like I have a 0.8 in there for all the losses. So it's saying you can get your total power times 6 in one day. 1,000 is just to go from kilowatts to watts, and then 80% total efficiency to get it back into the vehicle battery. Because again, we're charging a battery bank, doing AC conversions, and then going back into the vehicle. And I measured about 80% on the Tesla, so that's probably a good number. So those estimates, a full charge with the different cells would take, this is weird, this is saying it's taking longer with the better, more efficient panel. So something's wrong with the calculations here. This is weird, this is saying it's taking longer with the better. No, I don't have that efficiency number in all the cells. There we go. Okay, so there's our first kind of rough estimate, is 6 days with good sunlight. Now, that factor in there, what was it here? That 6x, that gets better when you have solar tracking. So on 2/3 of the cells, you'll get a like a 40% boost. So we could add, let's see, we'll add 2/3 of this, 2 divided by 3 of this. Oops. We'll add 2/3. This is just going to be an estimate here. So we're going to add 2/3 of our total power times that. So we're getting 2/3 of that times, we're going to get an extra 40%. So times 0.4. We're going to get an extra 40%. Oh, I need to divide by 1,000 in there. 2,000. Okay. So instead of 28, we get 30. So it doesn't add a whole lot, but it brings us down into, let me just kind of check those numbers again real quick. So we've got our, that times 6, we got 80% efficient, and we've got this, and we also need an 80% efficient there, or we'll just put 80% in parentheses for the whole thing, capture that. Now, if we had a DC to DC charger, this would be way better. That would probably be like 95 or 96% instead of 80%. DC charger, this would be way better. That would probably be like 95 or 96% instead of 80%. All right, so yeah, ideal conditions, you could charge the van up from completely dead to completely full in 6 days. Right, so yeah, ideal conditions. Let's see, what do we got in the comments here? Massive battery, yes. Scroll back up. I saved up to buy a Model 3 dual motor outright 2 years by using an e-bike and roller everywhere. Yep. Yep. I commuted to work for a while on a one-wheel, but just for fun, not to save money. Given the battery size, absolutely go for all the solar. That will be your bottleneck by far. Yep. Single axis tracking is about 30%. Okay. Oh, that's true. I might have been looking at 2-axis tracking, so let me change that to a 30% boost. And you're saying it adds about 30%, I'm assuming? Which brings us to another comment I've seen, is you could just make them slide out and use bifacials, and you could get a lot of power. So we'll look at that too here in a sec. Let me go back. So yeah, we're still right around 6 day for a full charge. But that doesn't include any energy use during the day too. So, you know, you're out there camping and you're running AC and having all this fun. But at least you're getting something, you're charging it. So, but let's take this and copy that into our other sheet here. Oh, can I just drag and drop? Let me try. Let me give it a shot here. Oh, now it's working. Let me give it a shot here. As soon as I... Oh, now it's working. Huh, okay. Yeah, I don't know why it didn't work before, but SunPower panels, which is not SunPower anymore, it's now Maxeon. So I don't know why it didn't work before, but SunPower panels, which is not SunPower anymore, it's now Maxeon. And then we can delete this out. And after this, I'll re-upload this document. So if you're in the, oh, hold on just a second. And after this, I'll re-upload this document. So if you're in the, hold on just a second. Okay, I'm back. So if you're in this document here, you can go to this Excel Tools tab, and you'll see it here. And it does keep track of revisions, although it's not as clean as it does for the models. So I'll give you an example. Everything here is revision controlled. If we go here, we can see all the versions. And let's say this is version 9 for the whole assembly. Once we put in a new document here, in the next version, it'll show it changing in here. So you'll see show changes. So you'll see the change made, and you can go back to older versions, but it won't rev it directly. I manually put in 1.01 just for my own benefit. But in theory, you could go back through every version that gets uploaded will always be here. So if we ever mess up or anything, it's just all there. But in theory, you could go back through every version that gets uploaded will always be here. So if we ever mess up or anything, it's just all there. Let's see, you could have And he says, could have a couple of wheels at 90, lower down on jacks, and rotate the RV almost in plane. Drive by GPS module time of day for night elevation azimuth. Yeah. You know, one thought was if you're at like the North Pole or close to the North or South Pole and the sun just kind of goes around in a circle, you could have the panels like this directly pointed to the sun, and then you could just lock the steering and you could just drive it in a big circle every 24 hours. And you get a ton of power that way. I saw, I think camping with Steve, he was way up north and he had a panel on his bus and he just put it on the face of the bus pointing to the sun. And he was getting, I think the rated power of the panels, because the sun was just pointing right directly at it. You get nothing on the top, but yeah, you could get a lot of power. You could get 24 hours of pure sun power that way if you just drove in a circle. You can get 24 hours of pure sun power that way if you just drove in a circle. All right, let's see where we're. Oh yeah, back in the Excel tool. All right, let's see where we're. Oh yeah, back in the Excel. So this is what we were going after, our system volts. And it looks like if we go with the best quality panel, our open circuit voltage is just under 400 volts. So whatever tracker we get needs to be able to handle 400 volt. Best quality panel, our open circuit voltage is just under 400 volts. So let's go back to Maxeon. Where did that go? I'm losing track of my tabs. Track my tabs. Oh. So let's go back and look at this one. So we got 50 volts overhead, so we're right at the top end, which is kind of nice. You want to keep that voltage high to keep your efficiency up. And we've got plenty of current per tracker. Let's see what our current is. I think it was 20 amps. Plenty of current per tracker. Let's see what our current is. Yeah. I think it was 20 amps. 450 volt at 20 amps. And our panels are 450 volt at 20 amps. What was the maximum current? Yeah, pretty low current. So we could double up and put 3 of these arrays on a single tracker current-wise. Not total power-wise, I don't think. 3 of these arrays on open circuit current. So we'll be running max 6-ish amps at 340 or 350 volt. I think this is kind of the ideal voltage when it's running at its maximum power point with full sun. And then this is if if you shut it down and you've just got open circuit voltage. System current. This is okay. So this would say if we had all 3 on the same string, which we don't, so we're not really worried about that number. Power. Okay, so this would say total system power. Same string, which we don't, so we're not really worried about that number. Panel array mass. Okay, there we go. 180 kilograms. Not too bad. If we keep the structure lightweight and aluminum, I don't think it's going to add too much weight to the vehicle. Not too bad if we keep the structure. Let's see. Interesting to see how you do your estimates. How did the estimates for the last run turn out? Did it end up in the correct ballpark? I think you went later and had less sun. Yeah, that was the big problem with the last run. In fact, let me see if I have that. You went later and had less sun. Yeah, I don't have it handy, but the biggest problem was shading on the panels, and it was so late in the year. That was what really killed me. And having it ground mount array is really difficult. I didn't have enough room to shuttle the panels around, so I've got all the panels laid out, and if I have a bump in the terrain, I can't just move that panel. I'd have to shift the whole array over. And that was just way too much work. So having it up, off the ground, away from any ground obstructions, and having solar tracking will be really good. I think I did a video where I went through the numbers. I did get a few days where I got pretty good power out of the panels, and I did hit the peak power of 6.4 kilowatt on my cannonball run, but it was only for a brief moment, and then it was all downhill from there. So, yeah, I think if I went in the summer, or kind of if I went this time, or maybe a little later, May we get a lot of rain, so it would be ideal time in terms of temperature to go. But the rain and the clouds, I mean, it's been cloudy and rainy all week. In fact, I've got a van I can go look at and maybe film some content there and get some more dimensions at a local dealer. They've got them, you can test drive them and everything. And then my neighbor has got a Hummer EV, and what I want to do is crawl underneath and check the drive units, because I'm pretty sure it has Hummer drive units front and rear, or maybe just rear. But I can read the stickers off the transmission, and we can tell exactly which drive units it has. They have, every GM transmission has a ton number, a TUN, transmission unique number. And in that number, it has a lot of coded information, like when it was made, which plant it was made at, which shift it was made at, which unit during the day it was made. So you can tell, when and where it was made, the sequence number it was made in, and all the details. And we can match that up with the bright drop and see if they are, in fact, the exact same Hummer drive units. I think they're a slightly modified version of the Hummer. They've derated the torque, and I think they've beefed them up for commercial use. So the Hummer is a consumer vehicle, so it's not designed like a semi-truck where it's supposed to just go hundreds of thousands of miles and never break down and be city traffic start-stop all the time. It's designed to get you to and from work, go have fun, but it's not a commercial grade design. I mean, it is, but the way they rate it. So the Hummer has 1,000 horsepower, but if you used 1,000 horsepower in something as heavy as this, you would destroy those drive units pretty quick. So if you used 1,000 horsepower in something as heavy as this, you would. All right. So we got the information on the solar panels in, and we were looking at inverters. So we got the information on the solar panels. Let's see, 250 volt back in the comments at 20 amps is scary AF on an RV though. Yeah, that is pretty high voltage. The Hummer actually, let's go look at that. Not the Hummer, but the bright drop fan. High voltage. The Hummer actually, let's go look at that. Not the Hummer, but the bright drop fan. They have a note here somewhere where they're talking about the high voltage. So everything orange says, warning, do not cut any orange colored high voltage cables. So in EVs, it's kind of standard practice. I don't know that it's a regulatory thing, but everything high voltage is orange. So you see any of that. They even have like don't drill here points so that you don't drill in. If you're drilling into the floor and you drill into a high voltage cable, that could be really bad. And the PV wire and the solar panels are designed for usually around 600 volt. And the way they're connected, if you disconnect them, you can't touch both and get shocked. And it should be an isolated system so that you would have to touch both positive and negative terminals to get shocked. But don't quote me on all that because I'm not an electrical engineer. But yeah, 400 volts is a lot. But don't quote me on all that because I'm not an electrical. This van does have an option for a 120 volt outlet, but it's really weak. It's 400 watts, so you're not going to do much with that. Option for a 120 volt outlet, but it's really weak. It's 400 watts. Could solve a thief problem. Yeah. Yep. They would not come stealing your cable if it's got 400 volts on it. Yeah. Yep. They would not come stealing. Yeah, so I still need to kind of get this working, paste that in and get that sketch working so we can get more accurate dimensions on it. Yes, I still need to kind of. That'll be helpful. The inside I did all those measurements myself. And I can pull those up, kind of give you an idea. Inside, I did all those measurements myself, and I can pull those up, kind of give you an idea. Inside, I did all those measurements myself. So I had access to one a while ago, and I just went through with a tape measure. So this is the charge port box, and this is the wheel cover. And you see there's a lot of detail, in the sketch here, they just give you the total length, but they don't show to where that is. And where that is depends on a lot. Is it this wall here? Is it where the garage door is? There's a lot of features that you have to avoid. So I think what I did for the internal volume is where this metal rail is. I use that as the length because there's a lot of inconsistencies behind that, but nothing protrudes past this. So if anything, we'll have more space than less space. But so yeah, so I went all through, got a bunch of dimensions everywhere. And I think it's 14 feet long. So you get 14 feet, and it's really big van. It's more similar to the box vans that they do deliveries in than it is the Sprinter van. Sprinter van's a lot smaller, so you're getting a ton of extra space. And here you can kind of see the rail for this door that has to be closed out. And you lose some volume up here at the top with that angle. But yeah, so those are the dimensions that I used when I modeled the interior. And if we open that up, let's see. So the exterior is kind of cartoonish. It's not very accurate right now, but the interior is pretty accurate. So if I section off the top here, we can take a look. It's not very accurate right now, but the interior is pretty accurate. So if I section off the top here, we can take a look. Oh no, come on. There we go. Section that. Oh no, come on. Extrude. So I think this is the sketch here. So if we go edit the sketch, you can see I pulled in all these dimensions off of my measurements, and I typed them in inches because that's how I measured them, but then it automatically converts to millimeters. So everything's in millimeters. By your numbers, does this look like you can beat your previous run? So that's for a cannonball run. I don't think so. But for me, this is more of, I'll show you the application. So I don't think so. But for me, this is more of, this is a render. So what I did was, I used to live in Texas, and I go to Galveston, hang out on the beach, go kite surfing, and I took a panoramic shot, and this is actually the car here, and I just kind of threw in the model. The idea is you can go anywhere you want, and you've got all the creature comforts of home, AC, hot shower, everything. So you can go out on an adventure, and you can get to really remote areas and not worry about, well, how do I get, if I get stranded there because there's no charge location, I'm in a super remote area, no problem, you can charge, and you can run everything there, and then you can just hang out. You can have the kids come in and hang out in the van if they get tired, and you can play out on the beach all day long. So that's kind of the application I'm thinking of. But it could have a lot more than that. So let's say we just do the solar portion. So you leave the whole van gutted inside and you just design the solar and the electronics. You could sell that as a package to a mobile machine shop, a mobile medical unit, a welder, construction work. They could have everything. Instead of running a generator on the site, they could just park the van out there and plug everything in and run it. And maybe they don't want all the extra solar tracking. Maybe you just have solar on the roof, and it has a bunch of batteries, and you charge it up at the shop, and then you take it out to the job site and run it. So you can take this version or this complete design, and you could option it out whichever way you want. And maybe they just want to build out their own thing. And with the model and it all being open here, they could just go in and start modeling up what they want to do with it. And you've got all the dimensions, which that's the hardest part, is to go get access to the vehicle and measure everything. So you could design it all up. Maybe a carpenter or a cabinet maker wants to put a bunch of cabinetry equipment in there and run all his table saws. So he could have table saws that could roll out, sit on the floor, power everything. So there's lots of applications. So that's kind of the idea. And you could do a cannonball run, but I don't think you'd set any records. I think for that, the best would be to get an Aptera if and when they come out, and come out with a really lightweight DC to DC charger. If you could fit these 300 watt panels in the back of the Aptera, they're really lightweight. They're much bigger. One of these is equal to 3 of mine. So if you could stack, 6 of them or something in the back, and then have the solar on top of the Aptera, then we're talking like a cannonball run in a couple weeks. And then maybe you could get 20 guys together that want to do a cross-country trip, and everyone, outfits their rig, and you kind of do it as a group ride from coast to coast. I think that would be the ideal for cannonball run. Outfits their rig, and you kind of do it as a group ride. Well, let's see. Back to the comments. I think that would be the ideal for cannonball run. Yeah, good foam and foil insulation takes up a bit of space too. Yeah, so that's something we got to put in there is the walls. And I've heard wool is really good for insulation, and what we would use to kind of attach something to these struts, these supports. So let's go to McMaster car. So let's go to McMaster. And what kind of, let's see, fasteners. I think they're called rivet nuts. Rivet nuts. Fasteners. I think they're called rivet nuts. And rivet nuts. These are not the one. Maybe it's rivet stud. No. Bulb hex. No. These are not the one. Maybe it's rivet. So I don't know if you guys are familiar with McMaster car, but pretty much everything they have on their website, they have a model for it. And if you don't know what you want, you can just look at pictures and start clicking on stuff until you find it. So let's go nuts. And if you don't know what you want, you can just look at pictures and start clicking on stuff until you find it. So let's see. And then maybe it's the studs. Oh, you can get a rivet stud. That's kind of cool. Maybe it's the studs. So what you do is you drill a hole and you drop this thing in there, and then as you tighten it, it deforms this piece and it grabs onto that wall and it secures it in place, and now you have a really rigid stud protruding out, or it could be a nut. So we go into the model here, and these supports, we can put rivet studs or rivet nuts along this, and then we can put some kind of walling or face up, put insulation in, and then put some kind of sheet on top, and then bolt it right to that structural element. Put insulation in, and then put some kind of sheet on top, and then bolt it right to that structural element. So I have to look and see if it's too scary. I'll ask my dealership to do it. Just reading the comments here. So I have to look and see if it's too scary. I'll ask my be fully charged every weekend. Yep. Just reading the comments. We'll be installing a 48 battery bank so you can charge that while driving. Every weekend. Yep. Yes and no. If we can get a DC to DC charger, no. But if we can't, then yeah, it's going to have a battery bank. And I'm not sure if it would be like a rack mount, where you could have this square area here. You could have a rack of batteries just coming up from the floor. And if you did do batteries, you'd probably want enough battery capacity that you could capture a full day's sun in one battery bank. So that would be a really large battery, 25, 30 kilowatt hours, which if you look at the battery I used in my Tesla, I think you need about 5 of those. So that would be 5 kilowatt times 5, so 25 kilowatt if you had 5 of those stacked up. And it would be a nice range extender. So let's say this is fully charged, the van is fully charged, you get out to the middle of nowhere, you've still got 25 kilowatts that you can dump into the van itself. The van is fully charged, you get out to the middle of nowhere, you've still got 25 kilowatts that you can dump into the van itself. Let's see, that's pretty neat. If you replace one person's RV with a solar one, that's like 10 commuter cars worth of fuel usage. Fuel saved. Wool and foil layers sound good. Bit like the shield on James Webb's telescope. Interesting. Yeah, the foil will reflect any thermal radiation. So any kind of heat radiation that wants to get in just through light would get reflected back out. That would add some too. So yeah, so that you need extra space. I tried to leave a little extra space on the bed here and the couch to put that in, but I need to wrap around and give extra space here too. So that, yeah, and then that'll also be something maybe you can mount to, although it'd be really nice if everything can fix to these studs and these aluminum structure ports with either studs or rivet nuts. And then you could, hopefully you could design everything and build it outside of the van and then precision place the rivet nuts with like a template or a jig or something. you just put a jig in up against the wall, and it would have predefined a drill template, and you could just drill, run all your rivet nuts in, and then come back with the facing that would be built outside, and just stick it in and bolt it together, so that you're not doing fit and finish work inside the van, which should help with if you get higher production volumes. The local fire department has a recover van which sole purpose is a mobile climate-controlled lounge. Oh, that's perfect. Exactly. That would be a perfect application. Yep. The van is very boxy, so simple foam panels can be used in many locations. Yeah, originally I was going to use those foam panels, but I heard they're really squeaky and noisy. So they said wool was best for RVs because it's quiet, it insulates really good. And another thought, too, is when you have a small enclosed space with solid walls, it gets kind of echoey and loud. So the thought was the walls would be some kind of slat design or something where they'd have gaps with a grill behind it, so it wouldn't, the wool, you wouldn't be able to pick the wool insulation out, but it would act as a insulation and a sound dampening, so that when you get inside, it's not only insulated, but it's kind of a quiet space. It's not real echoey and loud. Yes, foil to reflect if radiation is essential as form to reduce convection and conduction. Yeah, so I don't know. Maybe we would put foam, or not foam, foil right on the wall first, and then put insulation behind that. Or if the insulation already has a reflective layer on it, that you just stick to the outside. Maybe that's something that's already out there, and we could just use that. And then for thickness, maybe 1 to 2 inches. And I don't know if we want to mount flush to these aluminum structures. Let me just measure that and see what that thickness is. So that is, oh yeah, it's 1 inch. So the thickness of these supports as they extend out is right at 1 inch. So if we did 1 inch foam or 1 inch wool, you could mount everything flush to this support. Or if we did 2 inches, then we need some kind of standoff. And I don't know, maybe we could do some thermal analysis with 1 inch. Just look at the R value and do just make a quick box example and say it's this temperature outside, this temperature inside, see how much heat we would lose, and then run 1 inch and 2 inch, just run the numbers and see if there's like a real big difference, or if it's neglectable and you just say, yeah, 1 inch is fine. Foil on foam exists in sheets. Yeah, I think I've seen that before. Foil on foam exists in sheets. So yeah, so that's the idea for the walls, and then it would have to extend out. This area here is the kind of the pocket for the sliding door. So you can't get rid of this. And then over here, same thing, pocket for the sliding door. Build out some kind of shower in here as well with a curtain rod or something that extends out so you get more shoulder room. This hallway portion here is actually just a door opening, and I don't have the seats in there yet and the person. But there's plenty of room here shoulder-wise, so I'm trying to keep with that constraint so when you're walking in, you're not pinched or hitting your shoulder on anything. The couch does kind of protrude out, so I don't know, if there's plenty of chill space in here. And then the next problem is when the bed is up, how much space, do you have to duck to get in? Yeah, let me turn off that. We'll go inside. So let's say we extend up with insulation, so we insulate all this. So we've got at least an inch below this wall, and then we can extend up a little bit. But the most we're going to be able to get this bed up may only be here. It may just be, unless we make it shorter, which we could, because this is a pretty wide bed as it is. So let's just say we conservatively place it there. I think it would be like a duck to get in kind of scenario. Let's measure it and see. Let's measure from there to there. We are at 1.6 meters. Let's do feet. 6.3 feet. So some people could stand up comfortably. Most would have to kind of duck their head down. But if it is an office desk area, that might be fine. Stand up comfortably. Most would have to kind of. But it just kind of uses up space. It doesn't. When you have something in the headroom like that, it kind of makes the space look confined and tight. So maybe another option would be to rotate the bed 90 degrees, and then you could bring it all the way up almost to the ceiling. Although you still have the rail for the garage door, so maybe you wouldn't get that far up. Well, let's check the dimensions on the bed. Let's just see. Switch. So I think I modeled in a queen size. I don't know if I made the shortened version. So 75 inches. That's pretty long. Let's say shortened version. So 75 inches. That's pretty long. Let's say you could get away with 72. That's 6 feet. I think that would work for most people. And you'd still have room when it's down for your feet to hang off the edge because the van is much wider. Oh, hold on. 72 inch. There we go. In the width, we can leave that 60 inches. Now let's see how that looks. In the width, we can leave that 60 inches. Consider floor insulation too. Yes. Yeah. It has a floor in there that we can take out. It has kind of this polymer floor, but it's not very thick. It has a floor in there that we can take out. It has kind of this polymer floor, but it's not very thick. I don't know if it shows it here in the spec sheet. If I had to guess, it's maybe 3/4 or an inch thick. So if we do a wood floor and some insulation, we're probably going to lose a couple inches there. And wood is really nice to walk on. If you walk on steel all day long, it gets fatiguing on your feet. Just having some wood under you really helps. If you walk on steel all day long, it gets fatiguing on your feet. All right, so we shortened up the bed. Let's see what that gives us. All right, so we shortened up the bed. Let's see what that gives us. Not much, because we still have this wall here. We have to leave space there for insulation too, to kind of wrap it all the way around. So I don't know that shortening the bed really gets us much at this point. So I'll go back and just make it, return it to the original. So I'll go back and just make it, return it to the original. Yeah, so we'll just put in a full queen size bed, which that's actually pretty cool. We can get a queen size bed in a camper van. That's amazing. And then these two, this couch, which will fold into 2 bunk beds, is half of a queen. Actually, let me just check that, make sure. This couch, which will fold into 2 bunk beds, is half of a queen. Actually, let me just check that, make sure. Switch to that. Let me make sure. 75 inch. Yeah. 75 inch. Yeah. So you've got a queen size bed and 2 half queens. So you could fit 4 full-size adults, or in my case, the whole family could comfortably sleep. And then the thought is this will have maybe a hinge or something that folds up into a bunk bed during the day. And then the thought is this will have maybe a hinge or something that folds up into a bunk bed. Let's check on the live stream here. How is everything going? Let's check on the live stream here. How is everything going? Okay, yeah, we got 11 people on the stream here. Okay, yeah, we got 11 people on the stream here. Glad I was able to get the audio fixed. Otherwise, I don't know if I ended the stream and had to reinitiate it if it would mess stuff up. I'd probably send out a bunch of notifications again that there's a new live stream. But yeah, I don't know. I think maybe I'm about to wrap it up today. And I'll try and figure out how to get that better model in there so we can get the exterior dimensions more accurate. and not just the interior. I'm pretty good with the interior dimensions, although I would like to get the cab kind of fleshed out a little bit. And then we can start putting stuff in. You know, how are we going to mount the tables? Does a table raise and lower? Does a speaker lower? Is it just something you set out? You know, maybe it's just there's a cabinet underneath. You don't use these giant speakers. You just put them away and you put them out when you want to use them. And then the tables and everything can be rigidly mounted. And I was thinking of having like a pillar or a post at four corners that the bed comes down onto, kind of like a tapered cylinder, so that the bed drops down and locks onto those tapers, and it's real secure. And maybe it can lock down for traveling. You bring the bed down, you lock it in place, and tie it down so that if you're in a crash or something, you want everything really rigid. You don't want this bed to come knock you in the back of the head or something. And then having two passengers in the back, you know, how do you do seat belts and things like that? How do you tie that into the structure and make sure that you don't have any projectiles? If you were in a wreck, you know, everything's got to be locked down and safely secured, especially the TV or monitor, whatever stand you have, that it goes into a position where you can clamp it or fix it. And I'm sure we can find all that stuff on McMaster-Carr. It's not the cheapest, but they've got everything. And then you start ordering it, and then you start ordering more. You can go directly to, you can usually find the direct maker of whatever you're looking at and get a better price. So you gain some air by deleting that roof AC vent, replacing that with underbench heat pump. Yeah, I was kind of waffling on that. Should we have one of the typical RV ones, or have, the typical, maybe you have a unit on the back that's the, little AC, and then have a little, what do they call it, like a mini split, and then you have the AC portion inside the van. Although we still need a fairing. So I was thinking if we had a fairing just for the solar panels, that fairing might cover the AC unit just as well. And then you can keep it simple and just use a generic RV AC unit. So this would be driving down the road like this, and then you'd have some fairing that would kind of come out and cover all this and give you a nice arrow. And then all you have to do is you have this little protrusion out here, so maybe your fairing can kind of encompass all that space and give you a real nice arrow front end without changing the arrow of the van that much. And then you're going to get about the same range as you would with or without the solar. Yeah, everything in an RV is a potential missile. Yep. Now, I guess the one advantage you do have is it's almost 10,000 pounds. So F equals MA, you're going to win the mass argument. So if you're in an accident with something small, you won't decelerate nearly as quick as they will. But if you're in a wreck with a semi-truck or something, yeah, I'd want everything locked down really secure, especially if you got kids in the back. You want to be as safe as possible. And it looks like the structural frame on this thing and the bulkhead is pretty strong. Looking at the looking at the images here, they had one where it kind of showed the front end. Yeah, here. So you got this huge bulkhead roll cage. And then it looks like you have something similar in the back, and then you have all the structure between. So if it did tip or roll or something, I think you got a lot of structure there. It does have airbags in the front here and here. Although I don't think they're necessarily required for a vehicle of this class in the U.S., but that's nice that GM put all that in there. So, yep, there we got some airbag simulation. So. All right. Well, I think that's it for live today. I'll do some homework and try and get some more in there. And then I need to get a video out on this project. So once the weather clears up, I'll go out and film the actual Bright Drop van and compare it with a Hummer and get a video out kind of advertising the series. And if you want to contribute, if you're not already in the the Discord forum, I think there's a link I have in the description. You can join that, and that any chat you put there will stick. So if you have ideas or you want to paste something in, then we can use that for reference later, which is where I got this. TJ pasted this in there, so thank you for putting that in there. So I'll end it for now, and thanks, and we'll talk again later.